Today I'll be explaining the difference between bonding and anti-bonding molecular orbitals, and I guarantee you that after watching this video till the end you will be able enough to know the difference between these two molecular orbitals. So the illustration can be seen very much simple in hydrogen gas molecule, where one s orbital from one hydrogen atom combines with the 1s atomic orbital of another hydrogen atom. So these two atomic orbitals, 1s from one hydrogen and 1s orbital atomic orbital from another hydrogen atom, these two orbitals combine to form one molecular bonding orbital. This is the nucleus of first one and this is the second one. The two orbitals are formed. The first molecular orbital is this is the bonding molecular orbital, that is, you can say that assists in upholding the bonds between two nuclei, and the second molecular orbital, that is formed by the combination of atomic orbitals, is anti-bonding. So these two types, it consists of two lobes. This is the single orbital, molecular orbital, but it consists of two lobes. These two orbitals are formed by the combination of two atomic orbitals of different atoms, and you can see the space that is present between the anti-bonding molecular orbital, that is called node. So the bonding molecular orbital, that is sigma 1s, and the anti-bonding is sigma star 1s. The energy of anti-bonding is very much high. It's higher than the bonding molecular orbital, that is why it's shown with a star. So the bonding molecular orbital and the anti-bonding molecular orbitals are formed by the combination of overlapping of two atomic orbitals. So if we see the diagrams of these two molecular orbitals in a combined form, let me draw it. These two are the nuclei, and the major difference between bonding and anti-bonding molecular orbital is that the lobes of anti-bonding molecular orbital are they are not they don't assist the upholding of a bond. You can see that this is the bonding molecular orbital, and the space this is the anti-bonding, and the space occupied by anti-bonding molecular orbital does not lie between the nuclei. You can see the clear gap between the nuclei, and the probability of the electron is not in the gap, that is called node. If we can see the gap between these two pink lines. These two pink lines are the boundary of the anti-bonding. If we can have an electron in the separate lobe of anti-bonding, we can see that this gap is very much empty, and electrons are not present in between the nuclei. That is why they are called anti-bonding, because they are present away from the nuclei. So they are they don't assist bonding. But if we look at the electron that is present between the nuclei, this is present in bonding molecular orbital. You can see that if the electron is present in bonding molecular orbital, it occupies the space that is present between the nuclei, and this is the major difference between anti-bonding and bonding molecular orbital, that the bonding molecular orbital occupies the space between the nuclei, but anti-bonding molecular orbital does not occupy the space that is present between the nuclei. So although electrons are present in anti-bonding and molecular orbitals, but they do not assist in the formation and upholding of the bonds. So that is why they are called anti-bonding, and so that is why it is called anti-bonding. So I hope so it's very much clear to you now what is the difference between bonding and anti-bonding molecular orbital, and this is it. And keep studying the concept of it deeply if you want to know more about it. That's it. Allah Hafiz.